So I'm going to talk today about a number of things sort of around the general space of what programming tools do people doing data science need. And as mentioned, I'm going to focus especially on the needs of domain experts from non-technical domains. I'm also going to be talking about sort of what it has looked like to do work in sort of the program synthesis and program languages space in the past, aiming to work for end users, and maybe not always landing on something that is usable or useful. So I'm going to talk a bit in that context about need finding to make things that are going to be useful, and then formative assessment to actually figure out if things are usable. So I want to start by acknowledging that this talk is going to touch on a bunch of awesome work by my students, the folks in my lab. I'm not going to go through all of them here, but I will pop up the pictures again when we get to their work. We've been calling ourselves the Plate Lab for basically talking about approachable and inclusive programming languages and tools. And these are some of the amazing students. All the good stuff is from them. I also want to talk about one of the primary goals of this lab, which is to bridge the gap with folks from the social sciences who they have various needs, but they don't necessarily know how to do the traditional programming processes that we would expect from folks to get their automation needs accomplished. And the reason I say social science visionaries here is these are fields that have really long histories, sometimes centuries long, and they're really somewhat set in their ways in some cases. And so you have to go out and find folks who are willing to try techniques that might be somewhat riskier, start doing work that hasn't necessarily been possible for folks in their space before. And so building really strong, close collaborations with folks on the social science side has been really critical for our lab in actually getting tools adopted by them and making sure that they are actually useful and usable for them. So that's going to be a thread that runs through today's talk. A little quick background on me and sort of what has shaped my lab's direction. I started from a primarily programming languages background, both at sort of the undergrad level and for the first part of my grad school. But eventually realized that I really was going to be needing a bunch of HCI techniques in order to do the work I wanted to do well. And so one of the big things that I've been thinking about a lot, both sort of over the course of my PhD and as I've been forming my lab, is how we should be integrating techniques from HCI into a programming languages practice. And so I'm going to have a little roadmap to guide us through what we're chatting about today. So first, I mentioned that we've been thinking a lot in my lab about how PL should be integrating techniques from HCI. I'm then going to do a somewhat deep dive on Helena, which is a particular tool that we've developed that's focused on basically being usable and useful for social scientists. And I'm going to talk about how that tool and various other tools in the general space have actually shaped our approach for integrating HCI into PL. And then I'm going to talk a bit about how this looks so far and what the lab is sort of up to. So let's start by talking about sort of some framing for this talk, which is our thoughts on how PL should be integrating techniques from HCI. And so some of this is going to be pulling on some stuff that we put together recently for a little CACM article with Helena and Josh Sunshine. And basically, we had been doing a bunch of work in this general space for a while and starting to figure out that, you know, as much as there has been work for decades and decades on combining HCI and PL, there was a particular flavor of it that was most common, right? Obviously, people knew that, you know, programmers are users and they have some needs and it's something that people should be thinking about. But most of the stuff that had actually been done in that space, at least so far, it's focused a lot on evaluation, right? So let's build whatever crazy programming languages tool we have in mind, whatever crazy language feature we have in mind. And then after the fact, maybe we'll put it in front of some users just to see, okay, now that we've, you know, sunk a couple years of engineering and theory and really hard work into this, now let's put it in front of users and figure out, did we land on something good? And it's not to say that we shouldn't do that or that wasn't a really awesome sort of piece of progress for PL's techniques. That has absolutely improved a lot of PL work. I believe firmly that is good stuff that we should be having going on. But it's not the only way to land on good programming tools, and in fact, it's probably not the best way to guide us to really effective, really usable programming tools. And so some of the things that we wanted to call out as interesting things for PL to borrow from HCI and for HCI to borrow from PL, this set of messages is actually the things that we really thought that the HCI side could be using from PL. And so I'll go through these real quick because these will shape a little bit of the work that I'm talking about today, but I'm mostly going to focus on the next slide, which will talk about the other direction. But what we were thinking that the HCI side could really use from the PL side is, in part, programming languages are super powerful, right? As an interaction way of actually doing tasks, so a way to interface with some kind of automation, it gives users a lot of control. It gives them really powerful abstractions and a lot of flexibility. Then, on the PL side, we've been developing, especially in the last couple of decades, some really amazing guardrails, right? There are ways that we can actually enforce that people are doing good things with their languages, good things with their tools. And that's pretty cool and pretty useful for if you are giving someone the full flexibility of a language, how do you make sure that they're actually going to be able to use it in a way that is safe and effective? And then the other thing is there's been all this progress in the program synthesis space, which is basically ways of turning things that are not programs, or at least not traditional programs, into programs, right? How do we take something other than traditional code, use it as a specification in order to automatically write the programs that they're going to need? And so those are all techniques that we think can be really helpful to a lot of the HCI goals. And I want to quickly talk about the things that the PL side should be drawing on more from the HCI side, right? All of these are things that, it's not that they've never been explored, but it's things that we think are underexplored in these spaces so far. So the things that we're really excited for PL people to start doing more, and I'm going to emphasize a lot this first one, a lot of need finding, right? We've had this long history of people saying, okay, this is a problem that I personally have faced in my programming languages journey, and therefore I'm going to make this tool that will be useful for compiler optimizers, the 10 compiler optimizer writers who are working inside the C internals team, right? Whatever the case is, which absolutely awesome problems. It's good that someone is working on that, but that's not the only way to find important problems, important needs. And we're really excited about people starting to basically go out and look for the kinds of things that programming languages and tools can tackle out in the world. Another thing is we figured out that not every programming languages researcher is willing to actually run formative user studies. And so if we want to make it practical for these folks to actually make good design choices in the process of developing languages, of developing tools, we really are going to have to give them some kind of a shortcut. And we think that's probably going to end up having to be behavioral theory if we can develop enough of it that folks can start making these decisions without running user studies of their own. And then also this idea of iterative refinement. So believe it or not, this is not actually super common in mainstream PL. Often the idea is you start with a goal, you proceed until you have reached that goal, you then evaluate it, and that's kind of where we land, at least on the user evaluation side, right? There's not a lot of, okay, let's put this in front of somebody, let's see what's working, what's not working, let's go back, let's iterate. And so making sure that we're actually getting that kind of formative input we think is really important, and we'd like to see more of that happening on the PL side. Okay, so those are our three sort of thrusts of things that we are hoping to have showing up more in programming languages, and that's going to shape some of the work that you'll see today. So an example of where PL has started to try this, I mentioned briefly program synthesis, the idea of turning some spec, something other than code, and turning it into a piece of program, right, a piece of code. You might have heard specifically of programming by example, where the idea is that we have inputs and output pairs, and what we want to do is actually generate the program that converts each input into its paired output. Or you might have heard of the even more specific thing of programming by demonstration, where you're getting the input-output pairs, but you're also getting the sequence of actions the user took in order to actually transform the input into the output. So a little while back, I gave a little pop quiz to a synthesis workshop. And I asked them which of these things they had thought. So I am going to use program synthesis to make task X easier. Ton of hands for that. I am going to use program synthesis to make this task accessible to more programmers. Also, ton of hands for that. This last one, making tasks accessible to non-programmers, not as many hands, but still some hands, right? So this is definitely something that people in this space are thinking about. Then I followed it up with Pop Quiz 2, which was, do you regularly use a program synthesis tool? No counting your own one that you're building. And so I'll actually ask this question of the folks in this hall. Is anyone here regularly using a program synthesis tool? All right, we got one answer. Is it one that you built? Oh, okay, it's not one that you built. All right, great. And then the next question was, what about your non-coder friends? Anyone? Non-coder friends using program synthesis tools? Okay, Okay, so we got one hand for that first question. So that's pretty good, actually. That's better than I got at the program synthesis workshop. But basically, the lesson that I was trying to emphasize to them was, as much as we've been thinking about these goals of trying to make tasks easier, trying to make them more accessible to broader audiences, we kind of haven't been landing on it yet. And I think a lot of that is about not having listened to those lessons from the orange box, right? Not having actually put tools in front of users to see what's working, not having actually iterated on the things that we are demanding from them in order to get to the programs that they want. So that's something that I was trying to emphasize to that audience is, okay, how can we get to a better position? And basically, the background here is that a lot of folks, if they've seen a couple of demos of end-user program synthesis, they expect that the breakdown of people liking it versus disliking it is probably going to look something like this. And in fact, if we look at the whole history of tools in this space, unfortunately, it looks more like this, right? We have learned all of these things about what makes program synthesis tools that actually won't get adopted, that users don't actually particularly like, and unfortunately, not all that much about what they actually do like. I'm going to provide a quick call out to some work by these two students that is specifically studying, okay, if we put a program synthesizer in front of a programming novice, maybe someone from CS1, what are they going to actually be able to do with it? What is going to be confusing? What is not going to be confusing? What does it take to make it actually learnable? So that will be coming out eventually, but it's a little early to actually report on it. So I'll leave that there for now. Okay, so what we're going to talk about for maybe half-ish of this talk is a particular domain where we do have 2 decades of synthesis tools that have never quite met user needs and what it took to actually get to the point of meeting user needs. So now we're switching into our topic on doing a deepish dive on Helena. So my first question is, how many people here have written a web scraper? Okay, more hands than for use of program synthesis daily, so that makes a lot of sense. No, yeah, okay, so that was a solid number of hands. So I think folks here probably already understand that there's a lot of value in web data. I think people are increasingly realizing how much you can actually get out of scraping data from the web. But the trend that's actually most interesting to me is how the breakdown of who's in those pies is actually changing, right? So right now, a lot of the people who are actually getting web data, using it for things, are folks who have the programming skills of the people in this room, right? They can sit down and actually write a web automation script with one of the web automation libraries that's out there. But increasingly, folks from outside of a traditional computer science background are realizing how much value there is and how much you can actually learn from real-time data, whether it's just about the quantity you can get, whether it's about the sort of ecological validity, whether it's about basically getting data in real time. All of these are really important for folks deciding where to get their data and how to actually do the analyses that they want to do. So here are some of the things that our collaborators are working on in this space. I'm going to just emphasize one of these right now because we have limited time. So basically, the folks on the sociology side of this collaboration, what they're working on is how to help low-income families move to high-opportunity neighborhoods. Now, the background here is that there are housing voucher programs where the intention is to give housing vouchers to folks from low-income families if the place that they are trying to rent is under some kind of rent threshold, right? They don't want to overpay because then you can't serve as many families, but you do have to set the rent threshold in such a way that there are actually places in the high opportunity neighborhoods that fall under that rent threshold. And so if you're relying on every 10 years census data, and you're in a city where the rents are rising rapidly, this can be pretty tough. Pretty quickly, you end up with a point where the rent threshold is set in such a way that only the low-income, low-opportunity neighborhoods are actually accessible below that rent threshold. And then you have unintentionally produced a housing voucher program that is funneling people into those neighborhoods only. So that's not what we want. And what the folks in this space realized was that the way they can actually set those thresholds in a data-guided way, in a way that's actually going to adapt to fast-changing market situations, is to get real-time data from the web. So in this case, they realized that Craigslist and Apartments.com are providing a lot of really rich, really up-to-date data on what are the prices for rental units in this neighborhood versus this neighborhood versus this neighborhood. So we wanted to check out first whether is end-user web automation an actual real need. And so the first thing we do, keep in mind, I was mostly on the PL side at this time. I wasn't super promising in the HCI side. I didn't know a ton about how to do need finding. And so my first guess was, OK, let's send out to an email listserv. Is anyone going to need web data? And I expected to maybe get 2 or 3 answers. This happened to be a listserv of folks working from a number of different social science domains, specifically on urban data. But instead, what actually happened was there was a whole flood of responses, and it was really difficult to get any work done for the course of the next 24-ish hours. So basically, what we heard from that is that end-user web automation is indeed a real need, right? There is data out there. People do want it. And they unfortunately can't get it on their own, right? They were responding to our email because they hadn't been able to actually get it so far. And so this kicked off a set of need-finding collaborations that would go on for the next 3-ish, 4-ish years, and some of them would actually turn into long-term collaborations with folks in this space. And so the background here, the reason all these folks were reaching out to us and happy to get involved with the project is because web automation programming is really hard. So this is data on basically folks with computer science PhDs, well, folks in computer science PhD programs. How quickly were they able to actually accomplish a particular web automation programming task? And it turns out that even if you let them go for an hour, only about a quarter of them were able to actually complete the task. On the other hand, if you give them our tool, they can go ahead and get to 100% completion rate within 10 minutes. And in fact, this isn't just let me do this task in this time. This is all the way from I have never heard of the tool, Helena, before, all the way to I have completed the task. So this is, everything from watching the 5-minute demo video all the way to actually doing the task. OK, so let's quickly go through why this is so hard, right? Why is this actually such a challenge? So does anyone have a sense of why this snippet is not going to work? So the goal here is here's our web page. And we want to know what the price is. Anyone have a guess?
You've hard-coded a price into the code, so if you're trying to find the price for another item, it's not gonna do it.
Perfect, yeah. So this is not a particularly good way to find the price of this item, right? This is a good way to find the string 26.06, which if the price has changed, if we're on some other product's page, all of a sudden that's not going to work so well. So in order to actually figure out how to get the price on the page, over time, you're going to have to do a bunch of stuff to actually reverse engineer the page structure, right, the underlying DOM tree. Well, all right, that's pretty hard, but if that ended at there, right, like maybe that would still be manageable for folks. But why is this snippet not going to work? So here what we want to do is basically scrape the first item in Google's autocomplete. So why is this not going to work?
Because it's reactive, and so you need to wait time between entering the string and getting the results.
Super close. Save that answer.
Okay.
Anything else? Yeah, so I said programming within this space was hard, right? So the reason is actually that what's going on under the surface is not that this just automatically comes up when a string is put in this query box. Instead, because it is in fact a set of JavaScript handlers running and responding to any set of events you might want them to actually respond to, what's happening here is on a particular key entry event, you are going to get the response that is going to actually create this. And just putting the string that you want inside that box will never actually do this. So you could wait forever, and the box that actually shows the autocomplete suggestions is never going to pop up because you haven't actually triggered the event that is then going to cause the JavaScript handler to run. So in order to make this stuff work, you also have to be reverse engineering the JavaScript code that is running on the page. And now what about on this one? So here what we're trying to do is click on, say, this product variant, and then click on Add to Cart in order to get it added to the cart. Do you want to reuse your answer from before? Yeah. OK. So basically the problem here is that if you were a human user using this web page, what would happen is you would click on the second variant. It would all get grayed out. And that would be a visual signal to you, the human user, that we're waiting for something to come back to from the server, right? It's going out to try to get some more information. The server is going to provide us that information, and then the web page is going to get updated. We should wait until that happens. But nothing actually prevents you, as a machine user, from going ahead and pressing the Add to Cart. So if you do line 1 here, and then line 2, you will instead add the old item, the old version of the item, right? Whichever one was previously highlighted into the cart. And so you'll also have to be reverse engineering the communication with the server. So this is pretty tough. This is a lot to ask from even an experienced programmer, as we saw on the slide with the actual user study results. But it's also a lot to ask from folks who really don't have this training at all. And so one thing you might be thinking is, well, what if we just watch the user interacting with the browser? It seems like what's happening is the user is making some actions, this mouse clicks, those key presses, those various events. And then this browser is actually going ahead and serving data back. So what if we just sort of looked at those actions that the user is doing, popped them into some kind of artificial user, and go ahead and actually do it that way? And this would be the core idea behind programming by demonstration, which is the basis of the tool that we're going to present today. So PBD web automation is a long-standing dream, right? People thought about this general idea ever since it made sense to talk about Netscape Navigator and new versions of Windows 95, right? This is something that people have been thinking about. And the first thing that they thought was, okay, maybe people are going to want to extract tables from web pages. I'm looking at this web page. It looks like there's a table. Maybe we want to grab that out. The next thing people said was, okay, maybe we actually want to record a set of interactions that the user is doing and actually replay them for things like automating tests of web pages, that kind of thing. And then, around 2009, things got a lot harder. So for starters, even with web table extraction and web record and replay, we hadn't gotten all the way to the kinds of programs that the social scientists I highlighted on a few slides back were actually able to write the programs that they wanted. But also, the web got a lot harder. So it became much, much more interactive. And that basically made all of the challenges that everyone was dealing with in these existing tools even more complex, such that a lot of the old tools basically broke. So at that point, progress basically stalled. So we're going to do a quick little demo here. And I'm going to first talk through what is going to happen, and then we'll see the actual demo in practice. So what data should we collect if we want to learn when CS researchers peak? Where would y'all look? Would you look at a particular web page? Yeah, I would definitely look at Google Scholar. So let's start there. So what we're going to do is we're going to go ahead and open a browser extension. That's our little tool up there. I guess you can see the little text that says what it is. And then over here on the left, we're going to have sort of the control pane. And on the right, we're going to be interacting with something that is basically just our normal browser window. But what we're going to be charged with doing is demonstrating how to find information that goes in the first row of our target data set for all of the tables in our target data set. So say we want to collect information about authors and their papers, all authors, all of their papers. What we're going to do is collect information about that first author, and then information about the first paper by the first author. And so all of that is starting to appear over here on the left. And then when we're done with demonstrating, we can go ahead and leave it to the tool to actually write the program for us, right? So here we have something that is going to loop over the authors. It is going to loop over the papers. You can see here it has some nice names for things in the papers table. It doesn't know about names for the authors table, but it's happy to scrape them anyway. And then the program is going to go ahead and collect our data. So now I'll go ahead and let us actually watch the demo. So here's what it actually looks like when you're doing this. Collecting that sample data, we're going to go ahead and let the tool actually write the program for us. It has gone ahead and decided what to do. It is ready to collect our data. All right, and you can see it's collected the first couple hundred rows. So now, we rewind. I hope that after seeing that demo, you're saying to yourself, boy, it really seems like end-user web automation and program synthesis technology is pretty usable. And so why would we be in this situation so long where the actual reactions to PBD for web automation were, it wasn't getting adopted, it wasn't getting used, it just wasn't a good space yet. So let's take a look through some of the work that had happened before. So this is from a really beautiful paper by Tessa Lau in 2008, which is basically looking at, okay, what's going on with these programming by demonstration systems that don't work out so well? What's the things that it's happening? And one of the things she noticed was that repetitive demonstrations were a big obstacle for people. If they could say, okay, I really just want to change this tiny little thing, and I can describe the change in natural language, it's really frustrating to go back and give my 7th repetitive demonstration. And over here, she was, this is actually also a Tessa Lau paper, she was figuring out that sort of switching between multiple different kinds of demonstrations that they had to give was very confusing. And over in the Excel flash fill space, Excel flash fill is actually sort of the big success story of program synthesis, the most used program synthesizer that is out there right now. And one of the things they realized as they were productionizing it and putting it into Excel is that if you actually want this to be useful, usable, then it really has to get the right answer after a single demonstration, a single example. And this was sort of very intensely enforced that it had to be able to do that for most of the real queries that they thought people were going to be doing. And so there are a couple of problems here. So one, were these tools, these existing tools, useful? Were they helping the target audience do the tasks they actually wanted or needed to do? And we really just hadn't gotten there yet, right? We aren't just trying to grab tables. We aren't just trying to record a particular interaction and replay that same interaction. That's not what we're looking to do. And was it usable? And so no, I mean, based on what we were seeing from those sort of failure and semi-success stories, we were seeing that even though we're starting to have PBD tools, it's not enough to have them be programming by example or programming by demonstration. That's not enough to actually make them usable. So let's diagnose real quick what's going wrong. There's actually a common thread running through all three of these stories. So here they were frustrated about giving really repetitive demonstrations. Here they were confused by the need for having multiple different kinds of demonstrations that would all come together to produce one program. And here they want to get the right answer after just one example. So I think after looking at this, you'll say to yourself, well, it seems like if we could just do everything from a single demonstration, if we only get one example, then maybe the user is going to be happy. And so that's what we asked ourselves was, could we do PBD with just one demonstration? Now, doing it with a single demonstration is crazy if you're a program synthesis person, right? You look at that specification that you're getting from the user, and you say, oh boy, that is just way too ambiguous. It could be that after giving that demonstration, the user, right, the demonstration is, first author, first paper by first author. So maybe they want the first paper by each author. Maybe they want all the papers by all the authors. Maybe they want all the papers with more than a particular number of citations, all the papers that mention learning in the title, right? All of those are consistent with that single demonstration that we actually gave. So the observation that ended up driving our approach is that drafting programs is really hard for these users. As it turns out, however, editing is easy, right? They've had this particular set of training in some amount of programming. A lot of them have had about 1 semester of Python or R data analysis. Even in those spaces where they've had training, they don't actually just sit down with the blank page, right? They have this blank page syndrome. It's very intimidating to sit down with the open editor window. And they're not going to just go ahead and sit down and write out a new data analysis script from scratch. But what they are going to do is take the program that they used in class, the program that their collaborator is using, and adapt it for the task that they're trying to do right now. And so that's basically the observation that we were able to produce our approach around. So one thing here is we're going to need to make editable programs, right? Calling back to this quote here. We really do, if we are going to do it this way, we need to make sure that the user can actually read, understand, and modify the programs that they're getting back from the synthesizer. So what will make the tool usable? So one thing is it has to be single demonstration, has to be editable. We had definitely not reached that point so far in the PBD history. So nope, not yet. And so our approach here was, rather than doing the traditional PBD workflow where you put in a bunch of demonstrations, the synthesis algorithm takes it, turns it into a program, then you run the program, you pop out the output, the user debugs by looking at the output and thinks about, is that the right output? If they're not happy with it, they put in another demonstration. We get rid of that workflow, and instead we do a demonstrate once, revise anytime workflow, where the idea is the user puts in one demonstration, the synthesis algorithm produces a program. It may not be exactly the program the user is going to want in the end, but it's close enough that the user can now edit it until it reaches the point where the user is happy with it. And so this is the single demonstration element. This is the editable program element. That's what we think we need in order to reach usability. So let's talk quickly about why one demo really is so much better than 2 demonstrations. So obviously, we've already talked about the fact that it makes for happy, successful users. Another thing is it actually changes the constraints on us, the developers of the synthesizer. So one of the big challenges in synthesis is if you have to reach every single point in the program space, that's a really, really massive search space, and it's really hard to actually do that. So we get to relax that because we can just reach some of the points in the program space as long as they are close enough via edits to the program that the user is going to want in the end. Another thing is it changes all of the extra infrastructure we have to build up around the synthesizer, so we don't have to do this ambiguity detection layer or this demonstration solicitation interface anymore. And then another thing is it changes the programs that you can actually use programming by demonstration for. So whereas in the past you really couldn't do long-running programs, now we can. And so why couldn't we do long-running programs in the past? Well, if the way that you were going to debug it is by running it looking at the output, seeing if the output is right. And if your web automation program that you're trying to run is going to run for, 3 days, boy, that's going to be really hard to actually land on the one that you were looking for. Fortunately, in this case, where we're actually presenting them programs that they can look at, they can debug, it does become reasonable for them to actually debug even very long-running programs. So the way that we are going to reach this DORA approach is by developing usable drafting tools and learnable languages. Of course, these are also useful and usable outside of DORA workflows. We just happen to be talking about them in the context of this one workflow. So on the usable drafting tools, the techniques that we ended up using and developing were program synthesizers, dialogue-based program augmentation interfaces. And then on the learnable languages side, we spent a lot of time on reverse compilation and bi-level DSLs and some custom language abstractions. I'm not going to dive into all of these, but I'm going to do a quick tour through a few of these. So I'm going to highlight goal 1 and goal 3 today. Let's start with how we synthesize complex programs from a single demonstration. So we knew that what users need, this was based on some of that need finding work with real folks in this space, we knew that people needed multi-load data. So this is stuff that is accessed by clicking, interacting with forms, doing widget interactions, right? All of the stuff that you do when you're interacting with the web on a day-to-day basis, they need to do in order to collect their data. It's also looking for hierarchical data. So the data they want isn't just give me the list of all authors. It's give me the list of all authors and all of their papers, right? We have all of this hierarchical type data that they're looking to get. And so those are the constraints that we definitely needed to make in order for the tool to come out useful to them. Unfortunately, this is going to be a little bit hard. So we know that we need to actually get this kind of data. We definitely know that the tools that were out there were not there yet. But why is it actually hard? Well, if you're a program synthesizer, you're probably already getting a program synthesis person. You're probably already getting nervous when you realize that you're going to need nested loops, right? So nested loops are sort of one of the banes of program synthesis in general. And if you think about it as sort of how it expands the space of programs that you're searching, this makes a lot of sense, right? So if you think about only the programs that have no loops, well, that is a massive set, obviously, but it's somewhat manageable. It's somewhat reasonable in size. If you start thinking about all of the programs that have one loop, well, you're already up to a much bigger set. That's starting to look a little nerve-wracking. And in fact, a lot of program synthesizers cannot handle programs that even have one loop. If you're allowing multiple loops, boy, now it's really getting intense. The search space is massive, and it's going to be pretty tough to actually search that space. And so we hit this little fork in the road where we could go down the path of trying to make a smarter, faster synthesizer, right? This is the thing that people have traditionally tried when they have tackled this problem afresh. Or is there some other way? What else could we do other than just try to make a smarter, faster synthesizer? And so the thing that we eventually started thinking about was there are lots of different demonstrations that you could give in order to show a human user the kinds of data that you're trying to collect. So in our little working example here, maybe they go ahead and play around with a couple of the papers from this author, and then they show the list page where that author appeared, and they scrape the various things that they're going to want. That's a good demonstration. It would probably serve to explain to a human user what you're trying to actually collect. But another way you can do it is the way we did it in the demo that you saw, where first we collect information about that first author, then we collect information about the first paper by that first author. These are two very different demonstrations, and as it turns out, one of them is going to make it much easier for the program synthesizer to actually do their job. So if we allow all possible demonstrations, we really don't have any better approach than just searching through the whole space of programs until we land on one that produces the data that the user has collected. On the other hand, if we restrict it to demonstrations like the one on the right, we can be a bit smarter. And so basically, we can limit the user a little bit in order to make the synthesizer design much easier. And the idea here is basically entering into a contract with the user to get them to produce something that's synthesizer-friendly, right? For this class of synthesizer-friendly things, we know that we can build a synthesizer that is going to turn things in that class into the output programs that we want. For things outside of it, we just don't know how to build that synthesizer yet. But of course, we can go too far, right? We've seen a bunch of synthesizers that were doing things that enforced synthesizer friendliness, like demanding a bunch of demonstrations, and that crossed to the point where it was not user-friendly anymore. So what we want, of course, is something that's going to sit at that intersection. And basically, the way that we found to enforce this is just to have a contract with the user that will allow us to make a simpler synthesis process. So the contract with the user, we wouldn't explain it to them in quite this way, of course. But the basics of it is that you want to demonstrate the first iteration of each loop or you can also think of it as the first row of each table that you're going to be using or collecting. And you want it to be ordered from outer to inner loop. And we're actually helped along in this process by the fact that the web mostly enforces that you order from outer to inner loop, the way you navigate links. So this contract reduces the synthesis problem to a much smaller problem, because basically all we're having to do is take this straight line program that you see on the right and decide where should we add loops and over what. And so let's start by assuming that we actually know what are the tables of interest. This is a big assumption. We'll think about it again in a second. But if we assume that we know this, we can go ahead and say, OK, this line relates to authors. This line relates to papers. And basically all we have to do is go ahead and add a loop that goes before the first use of any of the cells of a given table and ends after the last use, right? So here we go. We've added in the appropriate loops. Now, we do actually have to find those tables, right? So assuming we know about the tables is a big assumption. Which interacted nodes, though, are part of a table on a page and which aren't? So for this one, who thinks that all of the highlighted in red nodes are part of a table that shows up on the page, even if it's just a logical table? Yeah, I agree, right? So we see that these elements all seem to be part of one row. It seems like the related elements on the next row would be maybe this, this, and this. It seems like there's basically a logical table set up here. What about for this one? Does it seem like there's another row of this same kind of data on this same page? Yeah, I agree. Seems like no. Seems like no. What about this one? Yeah, I'm getting some sort of like, partially, right? Like, it seems like these two probably aren't part of it, but these ones do seem like, okay, those probably correspond to here. And so basically the approach that we ended up using was formalizing basically the intuition that you're having right now. I'm going to gloss over the actual table selector synthesis problem a little bit, but basically it looks like this. We just want to use that same insight that YouthHel had about which elements that the user interacted with seem like they have corresponding elements in a similar structure, right? Now the computer isn't looking at it sort of visually the way we are, but it's looking at the underlying DOM structure to see if there are similarities. And so this has simplified the process of doing the synthesis pretty dramatically. So we've gone from having to search the space of all programs in the Helena language to the much more constrained problem of actually synthesizing table selectors, more doable, more manageable. And rather than asking the user to reverse engineer the web page, we are instead just asking them to learn this demonstration contract, right? It's not nothing, but it's more manageable. And users do indeed perceive Helena to be more usable than here the comparison is Selenium, which is a traditional web automation library, and also substantially more learnable. And also, of course, users are more successful with Helena. So this was the big thing, was we are most excited for them to be able to do these tasks that they want to do without running into too many obstacles. And yeah, I did want to emphasize again that these times include training time. We actually let them do anything they wanted for training, so they basically just had free range with the docs. Most of them did end up watching a 5-minute demonstration video before they actually started, and that's still, even with that, they end up in this under 10-minute time. Okay, I'm actually going to go ahead and skip over most of this goal 3 section, so we have a little more time to talk about the broader vision. But basically, this was sort of switching over from looking at usable drafting tools to looking over learnable languages. And one of the big obstacles is that it's actually pretty tough to get both robustness and usability, because for robustness, you need to get all of this stuff into the program. And boy, you really don't want to show that to even a programmer. You definitely don't want to show it to a non-programmer, right? This is gross. We don't want to show that. We would much rather show something that looks like this, right? That's much more friendly. That's something that the user might actually be comfortable looking at and editing. So how do we actually deal with the fact that we need this low-level language for robust replay, but we really want to show the user something more like this? Who thinks we should sacrifice robustness? Who thinks we should sacrifice readability? Yeah, right, that's not very satisfying. We would much rather just have both. And so the way that we actually have both is by showing the users a high-level view where it looks like this, but still maintaining the low-level view that we have in order to actually run it. And this is this bi-level DSL idea. Sorry, DSL is domain-specific language, where what we have is this representation that looks quite friendly, But it's actually being mapped from a low-level language, right? We have a reverse compiler that's going ahead and taking it to the version that we want to show users. And then as the user makes changes at the upper level, it can go ahead and be propagated back down to the low-level code via our custom program editor. And of course, there's some statements that don't even need that because they actually don't interact with the web. So this lets us synthesize these very huge, very messy, but still editable programs. OK, from here, I want to move on to talking a bit about the impact that this project, other projects in this general space, the various programming tools that we've been building, have had on our vision for drawing on HCI and PL work. So like I said, a lot of what we're focused on, a lot of what we've been doing, is working on programming tools for social scientists and domain experts from other non-technical domains. I'm going to use social sciences as sort of a catch-all term, but I really should read this as folks from domains other than computing who need programming for something. And what we're seeing, of course, is that there are so many people who want not just data, right? That was sort of the motivation for the earlier part of the Helena bit of the talk, but automation in some form, computation in some form. And right now, a lot of those people who want that are computer scientists. We're going to keep seeing a bunch of computer scientists want data, probably even more. But we're seeing so many non-computer scientists who are wanting and needing it. And we really feel that HCI-PL hybrid work can help us here if we can go ahead and actually make programming languages useful and usable for real users. And so I talked about this briefly early on, but I want to talk about it again now that we've seen sort of how the Helena tool came together. We really want to move away from this evaluative-only approach to using HCI techniques in PL. It's really been a few decades now of folks mostly coming to their HCI colleagues when they have done with a tool and they want to get it evaluated, right? From PL, that's sort of the common mode is, OK, I've built my thing. I know I should eventually see if it works for users. Let's see once it's done if it worked. And what we found in the process of this project and the various other projects in this space is that we really benefit from doing a lot of need finding, right? Working with real users and seeing what are they doing right now, what is working, what is not working, what kinds of things are they comfortable talking about versus not talking about. I didn't talk about how we helped these programmers actually parallelize their programs, but the way we actually did that was by noticing that they were very comfortable doing data deduplication and stealing all of the information they would use for that, and actually using that to parallelize and distribute their programs, which is something that we just wouldn't have even thought to do if we hadn't been there hearing about their data deduplication processes. So doing that need finding has really served both the tool design and the abstraction design, really enriching both the programming tools and the programming languages. And another thing I want to emphasize, this iterative refinement process. Even through, this particular project has gone on for a number of years now. And we definitely were discovering additional things that we needed to augment, things that we needed to modify, years and years into the process. Doing this iterative process is what produced the tool that actually a bunch of people are using quite regularly. Like the sociology example that I gave earlier. They are now at this point collecting rental data from 100 major metropolitan areas around the US every single day around the clock. And using this to shape housing voucher programs. So this kind of thing works because we actually did this iterative process with folks to get at what does it actually take to make these tools usable for them. And it has turned out to be a really impressive way to find sort of interesting and exciting programming language challenges, right? So in the programming languages space, there's a bunch of value given on just describing a fresh problem. This is sort of a magical way to just pop them out without even really having to do a lot of sort of hard thinking yourself. You get to just watch people, see what they are actually struggling with, and basically out of thin air produce these really exciting challenges, because so often the programming languages techniques that are already out there have not actually reached the point of solving the problems that these real users have. And so we really get this interesting way of coming up with new fun challenges to solve with the programming languages techniques. And we have a bunch of ideas for where this is going forward. So the needs of novice coders and non-coders, the needs that they have, they're so diverse, right? There's all these different things that they want to do. And one of the big things that we want to see going forward is that we're actually going to start soliciting more different kinds of input from the users. There's been this big focus on basically examples, sometimes demonstrations, although that has been fairly rare. And we really think that it's just not the only things that are out there, the only ways for users to express their intent. And so we have this sort of programming by X vision of what is it that is going to be natural for the programmer in quotes, to express to us, and how can we use that to actually get to the program that they need. Okay, so how this looks so far. I'm going to talk about how this has been shaping our current ongoing projects. I promise to get to the question prime of the thing within the next 2 minutes. So we have a bunch of ongoing need finding, right? I emphasized how important need finding has been for our work so far. And it's a huge part of our mission going forward is before we start diving in and trying to tackle the programming needs of these audiences, let's go in and actually see what they're doing right now. Let's see what's working. Let's see what's not working. And so Parker's project right now, he's looking at basically what people are doing with geospatial data. This is everyone from people who are already super comfortable using programming tools in this space, to people who are mostly using graphical user interfaces, to people who are just beginning to start using graphical user interfaces and are still kind of wandering around trying to figure it out. And he's focused especially on folks from 3 domains, so environmental scientists, journalists, and social scientists. And what he's figuring out is that a lot of the challenges that they have, they actually do share, but of course some of them are quite different. Another thing is that it's been really interesting to see how much these very same techniques work on people at sort of the other end of the spectrum for some definition of the spectrum, right? If these GIS users are mostly folks who really haven't been taught a lot of programming, the people on the functional programming side are at least often the stereotype is that they're kind of the nerdiest of the nerdy programming language users. So we really get to see the spectrum and seeing the same techniques working for folks all the way from the least experienced to the most experienced. And then also we have Lisa, who's working on some really cool stuff for a domain that I barely even knew existed until recently, which is climate economists. So figuring out what are the needs across these spaces. And I want to mention a couple of things here. So one is that thing that I mentioned of sort of how these techniques really can span the spectrum. So especially when I'm speaking with programming languages audiences, I really emphasize that, hey, you may see me doing all this work on the social sciences side and the non-technical domain expert side, but look, this also applies equally to functional programmers. Whatever audience it is that you are trying to build programming tools for, you can use these same approaches to figure out their needs as well. And then also the fact that it's just quite a diverse array of non-coders, right? So we are figuring out that audiences that we wouldn't have even necessarily thought of as having automation challenges absolutely are running into them, right? So probably folks suspected that journalists were having this kind of need, but I don't know if folks were expecting social scientists and climate economists to need a bunch of automation. Maybe you were. Maybe I'm just sort of in the dark there. But yeah, so we're getting all of these different folks with all these very different needs, and it's really exciting to see the different needs that are coming out of these findings. Okay, and this really, it brings us back again to my favorite little slide here on why I think need finding is so important. I also wanted to talk a bit about some of the tools that are already getting built up. So in particular, Helena here is working on tooling for journalists, and Rebecca is working on tooling for lawyers. Both of these tools so far are coming out of a larger project on processing really large, really messy, unstructured data about police misconduct. So basically, this is part of a collaboration with folks from the National Association of Criminal Defense Lawyers. One of the things they're dealing with is the sites that they work with, the defense lawyers that they work with, they know that some of the police who are testifying against their clients have previously lied on the stand or have other patterns of misconduct. And that's important for judges and juries to know, to have more complete information. And so one of the things that these students are doing is both working really closely with the folks in this space. So Helena is actually working with a bunch of journalists, including some who work right here at Stanford. And Rebecca is working super closely with both the NACDL and with a bunch of the defense offices that they actually integrate with. And so they're working on tools that will basically make it doable for folks to go from these big piles of messy, unstructured data into the structured data that then lawyers, journalists can use to actually make their analyses to figure out if a particular person's testimony should be trusted and that kind of thing. So this is part of a really exciting ongoing project, and one of the main collaborators here is Aditya Parameshwaran. There's a bunch of really fun stuff happening in this space. This is only one tiny sliver of it. Okay, I promised I would get to questions, and now I'm ready to get to questions. I would love to talk about either Helena, but I think probably the most interesting thing for us to discuss is sort of this broader message about how we're pulling in techniques from HCI into PL, but I'm happy to discuss whatever is exciting to this crowd.
we will have questions in the room, and we will also have some questions online. Sean can help us with the questions that come online.
That sounds great. That sounds great. Oh, so I think I saw your hand first. Do you want to?
So great talk. It was really excellent. I love your work. One thing that I wanted to ask more about is when you're working in the iterative design process with all these like non-coders and developing your synthesizers, like how are you thinking about power? And I guess I ask this because like as someone who builds tools for a lot of non-coders myself, like I'm always like sharply aware of like, oh, like I have all these skills of programming and stuff, and while I want to like help these people, I don't want to do so in a way that is like sort of like imperialist. Yeah, so how are you like sort of thinking about that as well?
Yeah, we think about that a lot, honestly, especially the more we're moving into spaces where there's really huge implications for whether these tools serve these audiences, right? Especially I was mentioning the police misconduct data case, right? This is a case where the usability of this tool, whether a defense attorney can use it within the 5 hours they have to prepare this person's case, that might mean the difference between calling out that, you know, a judge has previously found that this person lied on the stand or not. So a lot of what it has turned into for us is being really clear about what our goals are, being really clear, getting from them a really clear statement about what their goals are, making sure before we really enter into the collaboration that those are enough aligned that we both think we can meet some of our goals, and just being really straightforward about the fact that, you know, research timelines are a little unpredictable and there are a lot of promises we just can't make for them. So I think that's been the big thing. And then another huge thing for us has been the fact that we basically, when we ask them to share anything with us, you know, data is the normal place where people talk about this, but often for us, it's even just sort of their time, their process, the chance to actually observe them. We do make it clear in advance that this may never actually end up helping them if the tool design goes down another road, right? This may only help people in a related space, and we never get around to the particular challenge that they are going to end up demonstrating for us. So yeah, a lot of really open communication and being really clear about what they should expect from us. Thanks for the question.
We have a question on Zoom.
Thumbs up. See it
Can you hear me?
Yes.
Faculty, I've tried many of these tools over the years, and in fact, I think I have a publication on one at some point. And they always seem to break when I try real cases. Even flash fill, you know, sometimes doesn't do what I expect and can't debug why is it not doing it. So the idea of producing code as something you can edit is an interesting idea, but that idea goes back actually to some of the earliest programming by demonstration systems. In fact, one of the famous ones produced Lisp code, and the barrier to that was most users can't program. So are your users, you're assuming people have had, you know, at least, you know, a half year or a year of programming knowledge to understand that, because otherwise, you know, it's not usable for that reason. So I want to understand the assumption about who the end users are. So when you say end users, often people, it means anybody on the street could do it, and you know, it's unclear looking at code, even if it looks like Scratch, is usable.
Yeah, I love this question. So this has definitely, I mean, you know, the reason I emphasized the learnable languages element of it, in addition to the program synthesizer end of it, is exactly because we've had all of these problems with tools that are producing, say, Lisp, right? You can't expect someone to just sit down and pick that up in one sitting. On the other hand, it seems like if we're in a particular restricted domain, like, for example, web automation, where we can really match the abstractions that the user is having to understand to the abstractions that they are thinking about when they are doing this task by hand, it seems like we can get people to actually pick it up. Now, I'm going to preface what I'm about to say by saying that it's anecdotal, right? So we haven't done something where, because we are so interested, especially in serving social scientists, and because all of the ones we've interacted with actually have had some amount of programming training, our formal user studies actually do not cover any cases where it's just, you know, I have never programmed before. Having said that, you know, this tool has been around for a while, and we actually have supported folks who have literally no programming training in getting up and running with it. And we've even done that thing of, okay, let me sit down next to this artist and say, how would you do task XYZ if I give you no instruction? And they have figured out how to actually edit the programs to do that. Again, purely anecdotal. I don't want to say that this is like a really well-supported claim about this tool, but it definitely gives me hope that this is a direction that will actually make it possible for folks who really have no programming background at all to get up and running with this kind of tool. I really do think if we can surface the program that comes out and make it in a language that they can actually understand with really no training at all, I think we're on a good path. But yeah, I completely agree that this is one of the huge obstacles to this style of tool.
I will go. Could you talk a little bit more about how you find collaborators who you think have interesting needs? And you talked a little bit already about like setting clear expectations and making sure your goals are aligned, but like how are you reaching out to people initially? How are you building trust with them so they'll let you like see their data and their problems?
I love this question. So recently, we've gotten somewhat lucky that because we have a little bit of a track record, people are coming to us. Obviously, that's not a good sort of general trick. So the biggest thing that we have done, honestly, is have many, many conversations, right? So we might have 10 discussions with folks in a given space, and it turns out that one of those turns into a collaboration or turns out to have an instance of the particular problem that we are currently equipped to solve. So that's been a huge part of it for just finding the right people in the first place, is given that we have some sense of the space in which we're going to be building, how do we like talk to a bunch of people in order to find people who are their goals are going to be pretty well aligned with our goals. So that's a big thing for sure. And then once we have entered into a particular space and are working with a few collaborators, in terms of building trust, the biggest thing is, again, the open communication. The second biggest thing is if we have some kind of prototype or can build them some kind of hand-tuned thing, right? Something specifically for their needs, even if it hasn't solved the general problem yet. That is often enough to make the process worthwhile to them even in the short term. And then they start to see what would be the benefits of getting the tool in the longer term, and they're willing to actually go ahead and stick it out with us because they see how valuable that's going to be for them. Right, so in the case of something like a data extraction tool, right? If we can write them a hand-tuned data extractor for their particular data set and say, is this the kind of data you're looking for, right? This is something that serves both them and us, right? We learn more about, is this actually the kind of data they're looking for? Is the input that they would actually need in order for us to generate that kind of program something that they can provide for us? So we're learning a lot out of it. They are actually getting the sort of end process data that they want out of it. Everybody wins. So that's been a big thing for us.
Super interesting, thank you.
Yeah.
Hi, 2 questions. I'm glad you went first. It came from that. First question is like kind of related to PERS, where like you said you had a lot of people coming to you asking for collaborations. How do you decide filter of like who you collaborate? Like assuming like the number you have is much more than you even have the number to talk to, right? And then the second question goes on like a little bit in terms of like creation to not quite implementation, but like study and review and iterate, right? So like you created this program, you did a formal user study, and like it's available to download. Are you still monitoring what that is, seeing how people are doing, supporting it? Like what are like the follow-ups from there?
I love both of those questions. So on the side of how do we choose who to end up actually collaborating with, a lot of it is just about, okay, does the goal of this particular collaborator align with something that the students who are working on this project are really passionate about, right? So they're going to be most excited to do work on something that sort of aligns with their values and their goals in life. So that's huge for us for sure. Another big thing that we enforce that we're filtering for is that the tools that we are competent to produce are actually going to be useful to them, right? Like it would be great to work with someone who, you know, their sort of big push that they're working on is something that's completely aligned with my you know, absolute favorite cause or whatever, right? Like that's great. But if the tools that we are actually going to be able to build aren't the last sort of remaining barrier between them and the thing they're trying to accomplish, it probably doesn't make sense for us to be there with them, right? We're just going to end up disappointing them when that actually doesn't get them to their goals. And so that's a big thing that we enforce, that we filter on. And so far, we haven't reached the point where there's so many people who are really well, you know, aligned with programming tools goals that we're ready to get up and running on right away. Maybe someday that will happen, and then we'll have to have more of a filter. Yeah, that's a big thing for now. Can you remind me of the second question?
The second question is like you talked about Helena and how you did the formal user study. It was extremely helpful compared to what was currently out there, and it's already available like to download. Are you in any way supporting or like continuing to measure progress? That stuff you said about anecdotal, are you getting more data on that as more people download stuff about the future work?
I love this question, yeah. So this actually relates to one of the questions that we get pretty often, which is sort of how do you feel about telemetrics of some kind built into programming tools, programming languages even? So I think there's a lot of reasonable sort of approaches to have towards how much are you willing to watch your users. We have personally chosen not to do a lot of recording of what they are doing with our programming tool. This is for a number of reasons. So one is the expectations around how much data is collected about you when you're using a programming tool compared to when you're using, say, a web page are quite different at this point. It would be pretty unusual to have data collected about you when you're just using a tool. We have started to go down the road of if you opt in, we will collect some data, not for this particular tool, but for another tool in a related study. But really only if you're opting in pretty regularly. We make sure that there's interfaces for you to go in and say, okay, no, I need this bit to be cleared back out. Let me search for this string and make sure that has never appeared. Go ahead and wipe that bit of the data. Right? So there's a lot of extra infrastructure that we have to build up in order to sort of in a way that is respectful of their process and of their needs, actually collect extra information about them outside of a study setting.
Yeah, I was more of like number of downloads and stuff like that, or maybe surveys of like, are they coders? Like the similar things when you download like a regular program or something, they match number of people download. Sometimes they ask, are you a student? Are you able to see who's down? In terms of that, not like seeing what they search.
Got it.
If that makes sense.
Got it. Yeah, so actually the way that folks get the Helena tool in particular is through the Chrome Web Store. So we actually don't have control over sort of what data we're collecting from them. That all kind of happens invisibly to us. Now, having said that, there are definitely people who reach out for support. And so for those folks, we actually do end up getting a lot of information about, okay, who is it who's coming to this so far? Now, that's only a subset. Who knows who it is who's opting into actually getting in touch with us? That's not going to be a representative sample, but it gives us some idea of, okay, who's getting up and running with this right now. So formally, not a lot of follow-up on that. Informally, some follow-up on that. Yeah.
Sarah, unfortunately, we are out of time.
Yes.
But thank you so much for
Thank
the
you.
fantastic talk.
Oh, thank you so much. This is super fun to chat with y'all.